Today we are discussed about the verification of Lambert's Beads law. Our aim in this experiment is to verify the Lambert's Beads law for for calorimetrically, and the apparatus are used in this experiment is a calorimetrical cuvette, 10 ml pipette or graduated cylinders, 200 ml beakers, test tube rack, stealing rod and tissues, and the chemicals used in this experiment are 0.01 kml for solution and distilled water. Coming to the procedure in this experiment main aim is to know the concentration of unknown solutions. Here we are using the kml for solution, which is in the blue color. The higher concentration of the solution will absorb more light energy than the solution of lower concentration. Here we are taken the 5 test tubes and those are transformed in a small rectangular cuvettes and those are placed into the calorimeter or spectrometer. In this solution, when pipette is dissolved in the water, it strikes the photocell and it is used to impact the absorbance of each solution. The direct relationship between the absorbance and concentration is known as a Beads law. Here we can know the concentration of a KMnO4 solution by using the graphical representation. Here we can see the graph. In y-axis we are taken the absorbance and along x-axis we are taken the concentrations. By using this graph we can understand the unknown concentration of KMnO4 solution, and we can take a small volume of 0.0 mole of a KMnO4 solution and distilled water in separate beakers. Here we can see the table. We can take in the first test tube 2 ml of KMnO4 solution and we are adding 8 ml of distilled water and 0.02 moles of concentration is comes. And in second test tube we are adding 4 ml of KMnO4 and 6 ml of distilled water, then 0.04 moles of concentration is occurred. In test tube 3, we are adding 6 ml of KMnO4 solution and 4 ml of distilled water and 0.06 moles of concentration is occurred. In test tube 4, we are adding 8 ml of KMnO4 solution and 2 ml of distilled water and 0.08 ml of concentration is occurred. In test tube 5, we are adding 10 ml of KMnO4 solution and 0 ml of distilled water, then we get 0.0 moles of concentration. By this we can get the concentration of unknown solutions, and we can prepare the 5 test tubes in clean way so that we can observe the unknown concentration of the solutions, and we can wipe the outside part of the cuvette with the neat and clean tissues and hang the outside of each cuvette with the rivets side. Dislodge the cuvette with the pipette and pipette out the bar and calculate the concentration by using the formula. Here we use this formula to calculate the unknown concentration of the solution. The formula is concentration of unknown solution into atomic weight of atom into 54.94 into 100/1000. By using this formula, we can get the unknown concentration of the KMnO4 solution. By using this process, we can know the concentration of any solution. This is the best way to we can understand how to calculate the concentration of unknown solutions. Thank you. This is the KMnO4 solution. We are taking 2 grams in the first beaker and we should weigh this. Please weigh. And again we are taking 2 grams of KMnO4 in the second test tube and 4 grams in the third test tube, 6 grams in the fourth test tube and 8 grams in the fifth test tube. And we are adding 2 ml of water in the first beaker. And we mix it with a glass rod. Same as remaining test tubes. Adding 2 ml of water and again we are stirring with a glass rod. We are taking the another test tube and taken 2 ml of water and adding in this test tube, and we are again stir it with a glass rod. Same as we are doing for the all the test tubes, and at last we are getting the concentration for each solution. This is a Beats Lambert's law is used to verify the concentration of the solution.